Good afternoon, Yetans. So, our next unit that we're moving into is robotics. Ideally, we could do all the robotics in class, make the robots, and do all the programs directly onto them. But given the current circumstances of the lockdown, we're going to be doing a lot of this digitally. Behind me, and what we're looking very soon, is a program called GearsBot, that allows us to do that. So we can simulate, write programs, and perform challenges, specifically ones that I can make and send to you as we progress through this unit. So let's get into it.
Alright, so this right here is GearsBot. There's a link to it on Schoology, on the class website, and in the description of this YouTube video. We'll have a very quick tour through this, and then we'll go and write some basic code. So, what we have are a few tabs at the top. The first one is blocks. This is probably very reminiscent of Scratch. It allows us to take commands and put them underneath a section to start and create a program. Right next to it is the actual code. This is Python that is being created. We'll also notice that it says down here, here is where your code starts. This is all set up, and we'll have a look into what this means later on. But just to show you what this means, look at line 32 and 33, currently empty. I'll create a line of block code here, and it makes the line of Python code here. So motor A on at 20%. Run motor at port A at 20%. Now the great thing about GearsBot is this here, the simulator. So this here is our robot. We'll quickly run through the controls that we have here. So we'll start up in the right hand corner. We've got this one, which is super important. These are all of the sensors and motors attached to our robot. So if we zoom in on the little guy, he has a color sensor, this thing right here, which is currently sensing these colors, this value of red, white, and green, which is white. An ultrasonic sensor, which is this thing here, which is sensing the distance to the next solid object, the wall over there, which is 190 centimeters. A gyro sensor on the back, which senses what sort of rotation we're on. It's currently flat, so that's at 0. A GPS sensor, which is its X, Y, and Z coordinates. It also has a pen, which is this little spike underneath it so that it can draw stuff when we want it to. Now, in terms of motors, it has a left and a right motor. It also has an electromagnet, which is, I believe it's just these purple dots in the front. Maybe that thing there's the something else. Anyway, that is everything that's going into our little robot. We can add and change the robot as we see fit. Right next to it, we've got the camera. So I'm using the right mouse button to move around in the first default mode. We can also look from the top, and I'm moving the mouse scroll wheel to zoom in and out. These other ones are just to rotate around, and they're all basically from the top here. They're just resetting values. Alright, so we'll keep it on the default. Over this side is where everything is happening. So there's play our simulation, runs our code. There's currently none, so this isn't important. Reset our code. Reset our scene, sorry. This is to measure distance, so it puts down this little spike. You can see a distance changing, but we can click and it's the distance between these 2 points. So it's 84.7 centimeters, or we can see it's 109 on the y-axis and 23 on the x-axis at an angle of -7.8 if you wanted to do some sort of calculations. And lastly, probably one of the most fun things in here is the joystick control to control our robot. And in fact, if we have a look at the sensors, we'll notice that the ultrasonic sensor is getting smaller as I get closer. The gyro sensor is changing angle as he's moving around. The GPS values are changing. Even the color sensor changed as I moved off to white into gray. And the motors are turning a certain amount of degrees. The only thing not changing is the magnet, because we're not using it. We can also use keyboard controls to do that as well, using the arrow keys. Oops. And the like. Alright, so that is the basics of the simulator. Now, there's a few other things that we can do in the simulator, or simulation, and that's all up here. So I'll reset it, put them back in the middle, and have a look. So file, we can save both our blocks and our Python docs to the computer. We can also export the entire package all zipped up. We can load back in our documents when we want to continue on with them. Under Python, it's got EV3 dev mode selected automatically, which is what we need to be simulating. Pybricks is what we can actually use to program the robots in class, but it won't work in the simulator, so we won't worry about this one. Robot, we'll have a better look at this soon, but we can actually change our robot. There's a few default ones as well. Under worlds, we can change the environment. We can either select a world that already exists or go into the builder and create one. And help, we can have a look at documentation. The wiki is the best place to go for that. So let us quickly just have a look under robots and see if we can configure this little guy. Then we'll add some code to it. So robot configurer. Do we want to go to the robot configurer? Yes, we do. So we'll click go to configurer. So here is our robot. Here's all of the sensors down on the side, and his values that we can change about that sensor or motor. For instance, we can change the position of various things. We'll notice that it doesn't slide. We move it and then it automatically changes it. So I've just put it underneath him, which isn't really going to work for us. I'll put it back on top. Oh, so we want that at 2. Oh. 2. Alright, I'm going to change his body a little bit. I'm going to make his height a bit bigger. I'm going to make his width a bit bigger. And I'm going to make his length a bit smaller. Make him look a little bit like Wally here. Yeah, that'll do. Wheel diameter, I might make our wheels a bit smaller. A little bit smaller. Wheel width, I'll make them very thick, tank tready, and distance from the body doesn't particularly matter, but we can see the difference there. Color, of course, I'm going to change the color to a purple. And I can change a few other things. Just to show how to add things, click add. We have blocks, which are just pieces or more aesthetic. Sensors, most of these are on it already. It's just missing a touch sensor, which we'll play with later on. Articulators, these are different types of motors that we can add. We'll notice that in here there is a arm motor, which acts like a hinge, a swivel motor, which acts like a neck almost, a linear actuator, which is back and forwards, and a paintball launcher, in addition to the wheels. Other, we have passive wheels, or wheels that don't have motors in them, they just go with the flow, and a pin, which it already has. So I'm going to add a sphere, just to see how this works. So I'll click on sphere, because that's what I want to affect. I'm going to increase the diameter of it. Yeah, I'm going to move it back. Oh, back, back. Find the right axis soon. There you go, back so that it's just sort of sitting on the end like a little tail. And I'll move it up a little bit. Alright, so every part actually has some values of weight that aren't exactly said in here, but it will affect how our robot runs. So there we go, we'll make it pink and we'll make it slightly more opaque so it looks like it's made out of glass or something. Alright, so we've got our robot, he's all edited up, we're going to have to save him. So under File, we're going to Save to File. We'll give him a name and we'll call him Greg. Greg the robot. And there we go. So we'll go back to our simulator by changing the tab back. And under robot, I want to, well, first off, we'll have a look under select robot. There's a few that we have. This is our basic sensor that Greg was based on. There's also a paintball one with a gun on the back, a crane with an arm, a cage bot with a little like net, and a few others. Maze Runner here is quite cool. He's got heaps of sensors all around him. I'm just going to leave it as the default. In fact, I'm going to hit cancel. Under robot, I'm going to load a robot from file. And I want Greg the robot. There he is. There is Greg. So let's make Greg do something. I'm just going to do this in blocks to start off with, and then we'll talk about Python later on. So everything revolves around this thing here, when started. So this is when the simulation starts, do whatever's attached. I'm going to create, I'm going to make the motors run. So I need to know what port these motors are attached to. So I can jump back to simulation. And under robot, I can click on select robot. There we go. Here is our custom robot. Oops. And we can see it's got its dimensions, how big it is, its actuators, which are mostly its motors and the electromagnet. Left wheel is in port A, right wheel is in port B. We'll need to remember that. And it's also got its sensors that we'll use later on, are in different ports 1 through 5. So left wheel was in point A and right wheel was in port B, sorry. So let's run the simulation. So if we click play, when play is clicked, they run at 20% capacity. And he's just going to go straight into the wall. We'll notice that under here, once again, all of these values are changing. We'll stop him by just resetting it. Alright, let's make it check if he's going to run into the wall. And to do that, we're going to have to use one of his sensors. We're going to use the ultrasonic sensor, which we see measures distance. So if we go under sensors, we've got ultrasonic distance sensor. But we notice it's a little puzzle piece that connects to something. All of the major bits of logic are under the section called logic. If something, then do something. So if we'll grab one of those. If, and in this case, we'll grab the ultrasonic sensor on port A, on port, and we can select it, or we can select it, leave it as auto. If the ultrasonic sensor, well, we need to do some logic first. Under logic again, we'll grab that one. if the ultrasonic sensor is current value, which is measured in centimeters, is equal to, under math, we'll grab a number. We'll write 100. Now, this will trigger if the ultrasonic sensor's value is exactly equal to 100, but it's very hard to get a number that's in decimal to always be exact, so we're going to go if the ultrasonic sensor is less than or equal to 100, then do this thing in here. The thing that we're going to make it do is beep. So let's run this. It's running, it's 50, 60. It's under 100, but it didn't beep. The reason for that is that it runs through all of this code only once, and it does it all at the start. So it starts, it turns on, and it does it really fast, sorry. It starts, it turns on that motor, almost immediately turns on the next one. Then it checks right at the start, is it within 100, which it won't be. Then it'll beep, and then it's done. These continue to go because we've never told them to stop. They just start. So we're going to need to loop. And we'll do that around this entire chunk of code. So we'll drag it all inside. So repeat until false. And this little thing here says break out of loop. And we want to break out of the loop if we get into here. So if the ultrasonic sensor is under 100 centimeters, it's going to beep and it's going to break out. When we break out, there's nothing to do. So I'm just going to add stop motor on port A, and I'll get another one of those to stop the motor on port B. So now it should, following the logic of our code, it's going to repeat this, so it's going to keep checking it until it's told not to. And then it's going to check, so it's going to keep the motors running, which doesn't have to be in here, it could be above it. If the ultrasonic sensor is under 100, its value is under 100, so we're close-ish to a wall, then it's going to break out and stop the motors. So we'll run that simulation, just reset and play, and we're waiting for this value here, the distance, to get under 100. We should hear a beep, and then it should stop. Yeah, there we go. Our guy has stopped. So what I'm looking for you guys to do is using the logic of repeating until things happen, breaking out of loops, and you're going to have to use actually multiple loops or loops that repeat a certain amount of times. So we can actually go and add sections onto the end with numbers, for instance. Oops. Where's that number heading? There it is. Repeat until loops. Oh, sorry. Numbers are up here. Repeat a certain amount of times. So we get rid of that. What you guys have to figure out is how to make your robot complete a perfect square. So it's going to need to move the motors a certain amount of times, either turning them on. And I'll show you one more thing just on the side here. So this is all grayed out so that it's not going to happen. I'm going to move a single motor, the A, so the left one, at a certain amount of speed. Let's write 90% speed for a certain amount of rotations or seconds. I'm going to rotate the entire motor 3 times, and I'm going to have my program wait for this action to be completed until doing the next one. So if I run that, 1, 2, 3, and it gets to here, almost a perfect turn. And then if I put on a next line of code, just the same as over here to make my guy move, I'll reset, run that. I'll leave that with you.
So there's your challenge. Try to have your robot do a square, but also a little extra challenge for a bit of a beauty contest. Who can make the most attractive robot by the end of the week? Who can beat Greg the robot? Alright, see you later.